Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, so our first question here is explain how exposure to radiation can cause a tumour to grow. So the first thing to know is we could be talking about alpha, beta and gamma. It doesn't matter, they're all ionizing radiation that when it is incident on a normal healthy animal cell will change or affect the DNA of those cells. And once that DNA of those cells is affected, they are essentially cells that have been mutated, and those mutated cells can divide uncontrollably. And the massive cells that you get from these mutated cells dividing uncontrollably, that is what is called a tumour. Okay, next question. A man has swallowed a radioactive source. Explain whether he has been contaminated or irradiated. Which would be the most dangerous type of radiation to swallow? Okay, so firstly, he has been contaminated because if you have ingested it, then the source is inside you. So if it's inside or on your body, he could have touched the source as well, then we say that he has been contaminated. And the most dangerous type of radiation, if you've swallowed it, would be alpha, because it is the most ionizing, and that's all that matters here. The most ionizing will be the most dangerous, and since it's inside him and doesn't therefore need to penetrate the air or his skin to get to him, it doesn't matter that alpha is the least penetrating. It will be the most dangerous in the scenario. Okay, question 1 suggests what a teacher should do to protect themselves and the pupils when handling radiation in class. So first thing, your teacher should always be wearing gloves to avoid any kind of contamination from accidentally maybe touching one of the sources. On that note, they shouldn't be touching the source anyway with their hands. They should be using tongs, and they should be pointing the source away from them and away from the pupils, and make sure that the pupils are stood at a distance. This helps to protect you from any kind of irradiation that you would get from the source. Next, just to limit the time that you are exposed to the source for, so to not use the source over a long period of time, and to put it back in its box quite quickly after they've finished demonstrating whatever it is they need to demonstrate. Okay. Next, explain why radioactive sources used in schools are stored in a lead box. Okay, so we know that lead is good at absorbing radiation and even has the ability to absorb some gamma radiation depending on the thickness of the lead. So that's why we'd store it in a lead box, again, to stop any kind of irradiation. Why do medical professionals leave the room when performing scans involving radiation? So, if you're a medical professional and you're working with radiation, then you need to protect yourselves and make sure that you can limit your exposure to that radiation. One way of doing that is if you increase the distance between you and the thing scanning your patient, which is emitting some radiation, then that'll be good, because your radiation might not be able to penetrate so far to actually then reach you. The other thing, so reduce irradiation from that particular source. Okay, so explain how an alpha source in a smoke detector is able to create a current. What type of half-life should it have? So it's able to create a current because your alpha particles can ionize atoms within your smoke alarm. In other words, that means that they knock electrons off of those atoms. And those electrons that then get knocked off can flow through your alarm. And electrons flowing through is exactly what a current is. So you have a current. What type of half-life should it have?
Well, hopefully quite a long one, because you don't want to have to be replacing the source in your smoke alarm very often. Okay, explain why beta rather than alpha or gamma is necessary in monitoring aluminium thickness. So let's draw a diagram of the kind of setup that you would have for using radiation to monitor the thickness of a material. So you would have the source, and there's some arrows showing it emitting radiation. Then I've got my aluminium foil. Then on the other side of my foil, I have the detector. And the detector will measure any change in radiation levels that is incident on the detector. So, for example, if you were using alpha for this, they would actually all be absorbed by the foil, so you wouldn't get any radiation on the detector, so you wouldn't be able to monitor whether those levels are rising or falling. And for gamma, you wouldn't get any noticeable difference in the amount of gamma that's being let through depending on the thickness of your foil, because it would all be let through. So even if that foil was really thick, you wouldn't notice any great fall in the amount of gamma that's being detected. So you do need to use beta, and what will basically happen is if the level of radiation reaching the detector falls, that's because your foil is quite thick, and so it is absorbing all of that beta. And what might happen is your machine might then roller it a little bit thinner. Okay, so it will react to the detection of the radiation on your detector. Okay, explain how radiation killing cells can be useful. Well, it's not useful if it is killing healthy animal cells, but it is useful if it is being used to kill cancerous cells. So just like it can kill normal cells, it has the ability to kill cancerous cells too. So we can use it for cancer treatment. And in fact, we do use it for cancer treatment in radiation therapy to attack tumours. Okay, why does ingesting a source emitting gamma do limited damage to cancerous cells versus alpha or beta? And why might gamma be used in treatment? So it's less ionizing, your gamma, than your alpha or beta, which makes it less effective at killing those cancerous cells if you have ingested it. It's more likely to penetrate out of your body than alpha and beta, which wouldn't be able to do that. Okay, and why might it be used in treatment? Well, less useful if you ingest it to alpha and beta, but if it is external treatment where the person is being irradiated, then you would need to use gamma, because you would need the radiation to be penetrating enough to reach the tumour and the cancerous cells that you're trying to attack in the first place. And it is still ionizing too. It definitely does have the ability to still kill those cancerous cells. It's just not as ionizing as alpha or beta. Okay, explain how PET scanners use radiation for diagnosis. So in the notes, there's a whole list, I think it goes like number 1 to 7, of how these PET scanners actually work. But just very briefly, you have a radioactive tracer which you ingest. So that is something like a normal substance like glucose or something, and it has a radioactive isotope attached to that glucose. That is called a tracer. The patient ingests it, and as it moves through the patient's body, it gets taken up by your tumour and used by your tumour. And whilst it's there, it begins to emit some radiation. It actually emits beta first, and that decay in turn makes it emit some gamma radiation as well. And those are the bits we're interested. So gamma rays are then detected because the patient is put into a scanner and is surrounded by a detector. So gamma inside their body penetrates out of their body to the detector and is detected. And you use where the gamma radiation hits that detector to work backwards to determine where the source of that gamma radiation is coming from. You have loads of different gamma rays being emitted in different multiple directions, so that helps the detector, which is connected to a computer, to build up an image of what the tumour looks like.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, tips and tricks for this section. So if it asks what is the effects of high level exposures of radiation or exposure to radiation, good to always mention changes in DNA of your cells and mutating cells as a way of explaining how cancer comes about. And then if you're talking about death and radiation sickness, you can talk about it killing those cells. So that's the difference between those two things. Half-life of sources, basically considering whether you would like a long or a short half-life for your source when you're thinking about the uses of these different types of radiation. Something that doesn't want to be changed often, so something for monitoring thickness or your smoke alarm, or sterilizing food would be a long half-life. But anything to do with a patient where you don't want them to be radioactive for a very long time could be a shorter half-life, but you need to balance that with how long it takes to get the radioactive isotope from the source to the person, and to make sure that it hasn't decayed too substantially by that point, so no radiation would be detected by a detector. So that one's a bit of a balance, but something like 6 hours is good for that one. Matching the radiation to the danger and use, you want to consider how ionizing and how penetrating your radiations are. So alpha most ionizing, then beta, then gamma, gamma most penetrating, then beta, then alpha. And there'll be a balance between those two properties that you would need to mention if you're trying to choose a particular type of radiation.